Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.118. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.118. Find the value of current I1, I2 and I3 in given below figure. This is the circuit diagram of given problem. Inside this network we have to find the values of currents I1, I2 and I3. So without wasting time, let's proceed towards the solution. First of all, we have to label current through this branch. I am assuming current Ix is flowing through this branch in downward direction. Now we will try to find out its value. If we observe, this is a parallel connection and voltage in parallel connection remains same. So this 24 volt will also be appearing across 8 ohm resistance as well. Using this information, we can apply Ohm's law to calculate the value of current Ix through this branch. Ix will be equal to voltage divided by resistance. Resistance of this branch is 8 ohm while 24 volt is appearing across this resistance. So the value of current Ix will be 3 ampere. Now another parameter can also be retrieved using this information. This same voltage 24 volt will be appearing across this dependent voltage source because of parallel connection. So we can say that the voltage across this dependent voltage source, that is 4 times I1, is equal to 24 volt. Using this information, we are able to calculate the value of current I1. Voltage across this dependent voltage source, that is the 4 times I1, is equal to 24 volt. Now divide on both sides with 4 to calculate the value of current I1, that will become 6 ampere. From this given information, we succeed to calculate the value of current I1. Now we will try to find out current I3 by applying Kirchoff's current law on this node. At this node, two currents are entering, one is Ix and other one is I3, while only one current is leaving, that is I1. So Kirchoff's current law equation for this particular node will be I3 plus Ix minus I1. Entering currents are taken with positive sign while leaving current is taken with negative sign. Now inside this equation we know the value of current I1 and Ix, so we can calculate the value of current I3. For that purpose we have to replace the values of current Ix and I1. Ix is equal to 3 ampere while I1 is equal to 6 ampere. Subtract 3 ampere from 6 ampere, the answer will be minus 3 ampere, and place this minus 3 ampere on the other hand side of equal to calculate the value of current I3, that will become 3 ampere. Value of current I1 and I3 is calculated. Remaining parameter is current I2. For that purpose, we will apply Kirchoff's current law on this node. Here from this node only one current is leaving while two currents are entering. So Kirchoff's current law equation for this particular node will be I1 plus I2 minus 2 ampere. Entering currents are taken with positive sign while leaving current is taken with negative sign. In this equation we know the value of current I1, that is 6 ampere. So replace the value of I1 and subtract 2 ampere from 6 ampere, it will become 4 ampere, and place this 4 ampere on the other hand side of equal to calculate the value of current I2, that will become minus 4 ampere. So the values of currents I1, I2 and I3 in this network are 6 ampere, minus 4 ampere and 3 ampere respectively. So this was exercise problem number 2.118. Thank you. See you again in next video.